So let's place the cows one at a time and try to figure out what exactly need to be done. Placing the first cow at 0, 1 requires that we draw some sort of the axis, and we're going to place the cow here. Now, since that cow is the lone cow, we don't have any comfortable cows, so we're going to add to the output or print to the output 0. We're going to place the next cow, still 0. Next cow, 0. And as you place the next cow, we have to bring in another cow on the right side of the cow in the middle. So that increases our marker count to 1. So here I'm using the X to distinguish the marker cow from the actually placed cow. So the marker cow is a cow that we need to bring in to make sure that no one is comfortable. But this cow doesn't really exist. It is just a marker so that we know we need a cow there. Okay? So do that. Now, the next cow actually replaces the marker and gets placed right there. So that removes the need for the marker and reducing the count back to 0. As we bring in the next one, I believe nothing happens. As we bring in the next one, we create one comfy cow that now brings in a marker cow. So with that cow, the count increases to 1. So at this point, you notice that what we're actually doing is keeping track of the count of the markers. Okay, and then the next cow that we bring in requires another marker cow. So with that requirements, the count goes up. And finally, this is the interesting part, because one of the marker cows actually becomes comfortable. So if we are to bring in a cow, we have to make sure that all cows, including the brought in cows, to be uncomfortable. So that requires another one. And this time, this particular cow, the addition of that cow, increases the marker count by 2, thus increasing the count to 4. Okay. Now, at this point, you can see that this problem is a flat fill type of question. And you can calculate the complexity by simply keeping track of how many changes does each cell go through. Because as you flat fill, you continue the flat fill only if you are changing these cells. And cells go from being empty to be marked, and then gets an actual cow. Sometimes an empty cell will just get the cow. So the maximum amount of changes that each cell go through is 2. So that brings the complexity down to O of 2. Well, in this case, the grid is n by n, so 2n squared, which is n squared. So that's pretty small. N is only as big as 1,000. So this can only be up to 2 million, which is way below the threshold. Okay. So this will be the overall logic. We know that this particular approach works, and the complexity of this is pretty small. Yeah, that's just the flat fill question. And at the end of the day, you'll have to keep track of the cells, whether it has a cow or has a marker cow.